In this video, we're going to solve part C of question 12. In this part, the regions bounded by the curve and the x-axis are denoted by R1, R2, R3, and so on, as shown on the diagram here. And then we want to calculate the area of region Rn and write Rn in the form kn pi, where k is a positive integer. From our knowledge in calculus, we know that the area of these regions are just the absolute value of definite integrals. For example, the area of region R1 is just the absolute value of the definite integral from x1 to x2 of the function. Okay, so to begin with, we can first compute the definite integral of this function from xn to xn plus 1. And then we can find out what Rn is. Okay. So the definite integral from xn to xn plus 1 of cosine square root x dx. From our result in part A, it is equal to 2 square root x sine square root x plus 2 cosine square root x plus the constant c with limits xn plus 1 and xn here. So it is equal to 2 square root xn plus 1 sine of the square root plus 2 cosine square root xn plus 1 plus c, and then minus 2 times square root xn sine of square root xn plus 2 cosine square root xn plus c. Okay. Now because the graph of y equals to cosine square root x intersects the x-axis at xn's, because the graph intersects the x-axis at at x1, x2, etc. So cosine xn is equal to cosine xn plus 1, which is 0. Okay, so the integral then becomes 2 square root of xn plus 1 sine square root of xn plus 1 minus 2 square root of xn times sine square root xn. Also, the constants cancel out. Okay. Now let's compute the square root of xn plus 1. And similarly, the square root for xn. So let me do this on the right. So the square root of xn plus 1 is just equal to the square root of 2n plus 1 square pi square over 4. And this can be written as the square of 2n plus 1 pi over 2. And then the square root cancels with the square, so it is equal to 2n plus 1 pi over 2. And similarly, the square root for xn is equal to 2n minus 1 pi over 2. Okay, so the integral now is equal to 2 times 2n plus 1 pi over 2 times sine of 2n plus 1 pi over 2. and then minus 2 times square root xn, which is 2n minus 1 pi over 2 times sine of this term. So sine of 2n minus 1 pi over 2. Okay. So 2 and 2 canceled out, to here also cancel out. And notice that sine of 2n plus 1 pi over 2 is, so it is equal to negative 1 to the nth power. Because if you plug in some specific n, like when n is 0, you see that it is the sine 2n plus 1 pi over 2 is just pi over 2, which is 1. And after plugging some specific value, you will find that sine of 2n plus 1 pi over 2 is just negative 1 to the nth power. So the first term is 2n plus 1 pi times negative 1 to the nth power. And similarly, sine of 2n minus 1 pi over 2 can be obtained from just plugging some specific values of n, and then you will know that it is equal to negative 1 to the n minus 1 power. So the second term becomes minus 2n minus 1 pi times negative 1 to the n minus 1's power. Okay, so it is equal to 2n plus 1, it is equal to negative 1n pi times 2n plus 1. And here we got the minus sign here, so we have a minus 1 here and minus 1, n minus 1, minus 1 here. So combine these two, we get negative 1 to the nth power. So we plus negative 1 to the nth power pi times 2n minus 1. So the common factor is negative 1 to the nth power pi, and what are left are 2n plus 1 plus 2n minus 1. So it is equal to negative 1 to the nth power pi times 4n, which is 4n negative 1 to the nth power pi. So this is the definite integral of cosine square root x from xn to xn plus 1. So the area of Rn is just the absolute value of this definite integral. And from what we've just calculated, it is equal to the absolute value of 4n times negative 1 to the nth power pi. So it is equal to 4n pi. Okay, so this is the part C of question 12.